Hi guys, this is Miss Scott, and today we're going to cover the 8.4 notes in geometry. Before we jump into that, here's your bad joke of the day. What do you call a lazy baby kangaroo? A pouch potato. Ah. All right, so here is your essential question. Today we're going to talk about rhombuses, rectangles, and squares. So the question you will be able to answer by the end of this lesson is, what are the properties of parallelograms that have all sides and or all angles congruent? So the next three types of quadrilaterals we're going to talk about are rhombuses, rectangles, and squares. And before we define those three types of quadrilaterals, we need to talk about a biconditional statement. That is simply a statement that contains the phrase if and only if, which is a statement in geometry that means you can read it both ways. So the if and the then are interchangeable. So we'll look at a couple of theorems that have that statement in it. So first of all, a rhombus is a parallelogram. So it is actually a parallelogram, but the special thing about it is that it has four sides that are congruent. So it's a parallelogram with four congruent sides. All right, so you'd have to put tick marks on all four sides, and that would be a rhombus. All right, a rectangle is very similar. It actually is still a parallelogram, but in this case, it's a parallelogram with four congruent angles. And if those angles are all congruent, we know that they have to be right angles. So that would make that a rectangle. And then a square is actually a combination of both a rhombus and a rectangle. It's a parallelogram with both of those. It has four congruent sides and four congruent angles. So it's got both. It has all sides congruent and it has all angles congruent, or all right angles. All right, and we're going to look at some theorems that involve each of those three. First, we're actually going to focus on the rhombuses. So here are two theorems that deal with rhombuses. First of all, a parallelogram is a rhombus if and only if its diagonals are perpendicular. All right, so what I mean by if and only if, that means that if the diagonals are perpendicular, then it is a rhombus. So those two statements are interchangeable. So if we call this A, B, C, D, and if the only thing you know is that these two diagonals are perpendicular, what that means is then if and only if that ABCD is a rhombus. All right. So we'll use that theorem in a little bit to do some examples. The other theorem dealing with rhombuses is that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. All right, so let's again call this A, B, C, D. It's kind of like a B, that should be D. And if you have those diagonals again, what happens here is that these two angles are congruent, these two angles are congruent, these two angles are congruent, and these two angles are congruent. So the diagonals bisect each opposite angle. All right, so then if that is true, ABCD is a rhombus. Okay, so let's use those theorems to find some missing lengths and angle measures in examples 1 through 4. All right, so the first thing we're going to find is angle PST. And we can use these two theorems because they do tell us that this figure is a rhombus. So in the first example, the measured angle PST is this angle right here. Well, it turns out that we know those diagonals are perpendicular, so that angle T right there is a right angle. So we can find that third angle by knowing if we just focus on this triangle right here, those have to add up to 180. So let's take 180 minus that 30 degrees at angle P and that 90 degrees at angle T, and we will be left with 60 degrees. So that tells us angle PST is 60 degrees. All right, the next part is number 2 here, PT. Well, we know RT is 6, so PT also has to be 6. All right, the next part is dealing with the angle TSR. So angle TSR is this angle here. And from this theorem 8.12 above, we know that those two angles are congruent, so that also has to be 60 degrees. And then PR is just asking us for this entire length here. Well, we know each part is 6, so if we add those two pieces together, PR is 12. All right, so there's really no tricks with these types of examples. Really, it's kind of intuitive. It's things that you would think are true are, so I'm not trying to trick you here. Just go with your gut instinct and chances are you will be right. All right, let's look at another theorem. Now we're going to move on to rectangles here. Okay. All right, so a parallelogram is a rectangle if and only if its diagonals are congruent. Oops, don't want to use that pen. All right, so in a rectangle, the two diagonals that are formed are actually the same length. So if this diagonal is 10 centimeters, it turns out this diagonal here would also be 10 centimeters. So I'm just going to put some tick marks on everything here. All of those pieces of the diagonals are congruent. All right, so again, if we call this ABCD, if that is true, then it turns out ABCD is a rectangle. All right, so now let's use that to answer a question here. We're going to assume in the example 5 down below that this is a rectangle. They actually tell us it's a rectangle. And they tell us that the length from W to Y, this segment here, is 12 units long. All right, now if that's 12 units long, since this is a rectangle, we know that ZX is also going to be 12 units long. So what I'm going to do here, let's grab a different color. I'm going to focus on this angle here, and they want us to find this length XY, which I'm going to call lowercase z. So there's a few things that we can notice. So if we just focus on that right triangle right there, we know that angle Y here is a right angle. They told us angle X is 50 degrees, and this is Z. And we know XZ is 12 because that's the diagonal. And we're trying to find little z here. So we actually are going to use SOHCAHTOA here to find the missing length. So all that trigonometry that we learned in chapter 7 is still going to be useful. So I'm noticing that this 12 here is the hypotenuse. If we focus on this 50-degree angle, Z is adjacent to that 50-degree angle. So if we have adjacent and hypotenuse, that's cosine. We can set up cosine of 50 degrees is equal to our adjacent over our hypotenuse, Z over 12 in this case. Let's put a 1 under the cosine of 50 and go ahead and cross multiply. So 1 times Z is Z. And over here, 12 times the cosine of 50 will give us our answer. So if you plug 12 times cosine of 50 in your calculator, you should end up with about 7.71. All right, so that is your length for Z. Let's just put that in a blank that would give us xy. So there is our answer. Xy is 7.71. All right, so now the last couple of examples are going to deal with squares for the last example. So if you flip to this example 6 and 7, they tell us this figure is a square. So we know a couple of things. First of all, to find the measure of angle HGD. HGD is this angle here. If we go from H to G to D. All right, so that is the entire thing we know is a right angle. And since this is a square, well, a square is also a rhombus, we can just take 90 degrees and cut it into two pieces. And that half there, angle HGD, would have to be 45 degrees. All right, and to find HF, well, if this is a square, this is 5, this is 5, this is 5, this is 5, so HF is 5. All right, so in our last set of examples, we're just going to name each quadrilateral type for which these statements are true. So it's equilateral. All the sides are the same length. We know that is true for a rhombus. And that is also true for a square. All right, now if you'd like to pause the video and give these a shot on your own, that would be a really great way to see if you are comfortable with naming these types of figures. But we're going to plug along here. So in number 9, diagonals are not congruent. Well, if we go back to our theorems, looks like they're not congruent in a rhombus. They are congruent in a rectangle, and then it turns out they would also have to be congruent in a square. So they're not congruent in a rhombus, and they're also not congruent in parallelograms. If we think back to our section 8.2, talked all about parallelograms, so it wouldn't be true in those two, or they would not be congruent. Okay, number 10. It can contain obtuse angles. Well, that's not true in squares and rectangles because those are all 90-degree angles. They're all right angles. So you can have obtuse angles in parallelograms and in rhombuses. All right. It has no acute angles. Well, that's true in squares and rectangles because those have all right angles. All right. Okay, number 12, all 4 angles are congruent. Well, that is actually the same answer as number 11. They're all right angles. In squares and rectangles, all the angles are congruent. That's actually in the definition of each of those shapes. And last but not least, 13, both sets of sides are parallel. Well, since rhombuses, squares, and rhombuses are all parallelograms, that is actually true in every shape we've talked about so far. It's true in a parallelogram, it's true in a rhombus, opposite sides are parallel. It is true in a rectangle, and it's true in squares. So that one's true for everything that we've talked about. All right, well, I appreciate you guys tuning in. Make sure you like the video, subscribe to my channel if you've been enjoying these geometry videos. And if you guys have questions, feel free to comment down below, and we will see you guys next time. Take care.